In this quick review, we want to talk about the general multiplication rule for independent events. So just recall what it means for events to be independent. So if you have two events within probability statement, if they're independent event, what it means is the occurrence of the first event does not impact the occurrence of the second event. And so we're going to introduce what's called the general multiplication rule for this. And it works like this. If E and F are independent events, that's really important. They need to be independent. Then if I ask a question like, or you're asked a question like, what is the probability that E and F happen? What is probability they both occur? E and F both occur. That's going to be equal to the probability of the first event just multiplied by the probability of the second event. So whenever you see the and statement, the and right here inside of probability generally is going to mean multiplication. All right, let's work an example here. Just see this. So suppose a manufacturer of exercise equipment knows that 10% of their products are defective. What that basically means in terms of probability is if you select a product at random, the probability it's defective is 0.10. They also know that only 30% of their customers will actually use the equipment in the first year. So what that means is if you select a customer at random, the probability they use equipment, and I'm just going to put use equipment, but it's use equipment in the first year, is 0.30. All right. If there is a 1 year warranty on the equipment, so basically what that means is if you get a defective equipment and you realize it's defective within the first year, you can get a new exercise equipment, turn it in, and they'll replace it. Okay. So what proportion of customers will actually make a valid claim? So I'm going to change this a little bit to what is the probability the customers will actually make a valid warranty claim? So probability of valid warranty claim. So I'm just going to write what is the probability that there is some claim. Well, what needs to happen, okay, for there to be a valid warranty claim? Well, first off, they have to get the customer has to have a defective exercise equipment. Okay, that's one. That's the first thing. But like if you don't use your equipment, then you won't know if it's defective, right? Like if you buy this exercise equipment, it just sits in your house and you don't use it, you don't know if it's defective or not. So not only does it need to be defective, and you need to use the equipment. So it's probability that for a valid warranty claim it needs to be defective, and you need to try or use the equipment. Well, I see this and that generally is multiplication, and so you just have to ask, are these independent events? So the first thing is if it's defective, is that going to impact if I actually try the bike? Like I won't know if it's defective or not. So yeah, these are independent events. So this is just the probability that the bike is defective times the probability you use the equipment. Well, look, we know what these are. The probability it's defective is 0.10. Probability you use the equipment is 0.30. So when you multiply that, that's just 0.03. So even though 10% of their products are defective, basically really only 3% of people will actually institute a valid warranty claim. All right, so this is just two events, right? Defective and the use equipment. We can actually expand this. All right. So this is a general multiplication rule for independent events for n events, not just two events. Okay. So the multiplication rule for n independent events. If E1, that means event one, E2, E3, all the way to En are all independent events. And you're asked the question, hey, what is the probability this and this and this and this happens? Well, as long as they're all independent, you would just multiply their corresponding individual probabilities. All right, let's try one example with this. Suppose you flip a coin 5 times in a row, okay? What is the probability you get heads 5 times in a row? All right, so you're going to flip a coin 5 times in a row. I want to find the probability of 5 heads. Well, look, I'm going to write this. If I want 5 heads in a row, the first flip is a head. I'm just going to write first is a head. First is an H for head. And the second time I flip a coin, second is a head. And if I want 5 heads in a row, that means then the third flip is a head. And the fourth flip is a head. And finally, the fifth is a head. Well, look, you just got to ask yourself, are the coin flips independent of each other? Meaning, if I flip head on the first flip, is that going to change probability I flip heads on the second one? No, absolutely not. So this would be, what's probably the first coin flip is a head is 1/2. Second coin flip is 1/2. Third coin flip is a head is 1/2. Fourth coin flip is 1/2. And the fifth coin flip is head is 1/2. So this is just 1/2 to the fifth power. Well, multiplying fractions, 1 times 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, 8, 16. Probability you would flip a coin 5 times and you get heads 5 times in a row is only 1 out of 32 times you would do that. So very low probability. All right, as always, this was just a quick review of the formula. If you need additional support, please reach out to your instructor.